Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. Welcome to Polygons in the coordinate plane, where we're going to take all of the rules that you might know in geometry and we're going to throw them all at you so that you can classify by sides and angles. So let's just go ahead and kick this off. We're in the coordinate plane, so you know we're going to be graphing. All right, I'm going to give you 3 points. A is going to be at 4, 1. B is going to be at 2, 7. And C is going to be at 8, 5. Already you should know that because I'm giving you 3 points, this is going to be a triangle. But what type of triangle? Is it scalene, equilateral? Is it isosceles? Is it acute? Is it obtuse? Is it right? How do we know? So the first thing we're going to have to do is we're just going to have to graph it. I'm only going to draw the first quadrant. We could do this without graphing, but I think it's just better with graphing. And I'll also work on how fuzzy that is. There we go. So I only use the first quadrant because A, B, and C had positive coordinates. So 1, 2, 3, 4, 1. 2, 1, 2, 3, 4, 5, 6, 7. This was at 4, so 5, 6, 7, 8. 1, 2, 3, 4, 5. Now, I know we could guesstimate, but that's not really what we're about here. We're about knowing exactly. So to classify by sides, the first thing I'm going to need to know is how long each side is. So I need to know the length from A to B. Well, the distance, I should say, from A to B, not the measure. That's going to be the slope, M for slope. And there's a reason why we're going to talk about slope if we need it. Okay, distance from A to B, the distance from B to C, and of course, the distance from A to C. Now, we could use the distance formula, or we know that we can do A squared plus B squared equals C squared as well. So let's just do A to B first, and I'm going to pencil that out. So if I turn this into a right triangle, we can see that it's 2 wide and 6 tall. So we'd have to do 2 squared plus 6 squared equals that hypotenuse squared, right? So then we would be doing the square root of that. Okay, so 4 plus 36, that's the square root of 40. And I know that simplifies. I'm not going to cover that right now, but I know it simplifies to 2 squares of 10. Okay, B to C. So 1, 2, 3, 4, 5, 6, 1, 2. So it's 6 and 2 again, right? Same numbers. So again, the square root of 40, which is 2 squares of 10. And then 1, 2, 3, 4. 1, 2, 3, 4. So that would be 4 squared plus 4 squared would give us our hypotenuse squared, so that would be 32. And the square root of 32 is 4 root 2. Okay, so by the sides, we can see right here that 2 sides are equal. And anytime you have 2 sides that are equal, you have isosceles. Okay, now let's look at the slopes. And if that doesn't help us, we'll go ahead and we'll go even deeper. Okay. So the slope from A to B, so, well, we work left to right. So we'd have to go down 6 and over 2, which is -3. We also need the slope for B to C and the slope for A to C. Okay. So let's see, this is downhill again, down to an over 6. I'm going to switch pens back. Okay, so these are both downhill, so they're not perpendicular. The one that we really think could be perpendicular could be right here. We'll check that out. A to C, up 4 over 4. So 4 over 4, that has a slope of 1. So that is not perpendicular to either line because when I multiply any two of these together, they don't multiply to -1. So this is not a right triangle. It's isosceles, but it's not a right triangle. Okay? But we know A to C was 4 square roots of 2. B to C was 2 square roots of 10. And A to B was 2 square roots of 10. And we further know that this angle and this angle are the same. So if we could only find the measure of angle B, we'd be solid. However, why do I not want to do that? Actually, if I find any one angle. So 2 square roots of 10 is 6.3, and 4 square roots of 2 is 5.65. So this is smaller than that. So this is the smallest angle, so we will go ahead and find B first. Sine of A goes with 2 square roots of 10. Sine of B goes with 4 square roots of 2. Sine of C goes with 2 square roots of 10. The law of sines has failed us. We can't fill in top and bottom. Okay, well, shoot. Guess it's on to law of cosines. So B squared equals A squared plus C squared minus 2A C cosine, and I forgot to put in B was 4 square roots of 2. Okay, we have that all filled in. And it's just habit that I utilize the reduced radical form. This one might have been a little easier to type in not using the reduced radical form, but I guess I've been doing math for so long, it's just habit. So 4 square roots of 2 squared. That's 32. That makes sense because it was the square root of 32, so when you square it, you're back to 32. So that means the others are going to make 40 and 40 respectively. So 40 plus 40 minus, okay, 2 parenthesis 2 root 10, 2 root 10, 80. Okay, combine like terms. Guess that should have been a capital B. Sorry about that. Now, remember you can't make this 0. They're separate terms because this is included in that. So we're going to have to subtract 80 to the other side. We get negative 48. We're going to divide by negative 80. We get 0.6. Then we're going to inverse cosine. So we can get that. And we find out that we have an angle of 36.87 degrees. I'm going to go ahead and just write 36.9. any of you who said I couldn't type in a calculator today, you were right. I accidentally put type 0.8. I should have had 0.6. My angle is 53.1. So again, make sure that you're typing correctly in your calculator. I had to go back and double check, and I did have that typo. So typos and calculators are actually the biggest thing I see in my classroom as mistakes. It's not the math. Someone's typed something wrong in their calculator, and they go through and they get all this work, beautiful work, and they get the answer and it's wrong, and so they erase it all, and then I come back and we do the exact same thing and they get it right, and they're like, boop, I got it wrong before. Check your calculator typo. If you don't have an answer correct, if you have someone close by that can help you, I would have them just compare side by side before you erase everything. It could be just as simple as you type something wrong in your calculator. Once we can bring attention to that, our world gets a lot easier. Okay, so we found out that this was 53.1. So now let's find the other two angles. Now we know they have to be the same. So we know we have 180 is going to equal that 53.1 plus angle A plus angle C, but they're the same because we had two sides the same. So we don't need to use the law of sines to solve for one of these. We can just use our basic algebra. So I'm going to subtract 53.1 from 180, and that'll give me 127. Or 126.9, sorry. And that will equal 2x, because x plus x is 2x. So when I go ahead and I divide that by 2, we get 63.45 degrees for each of them respectively. So now we know we have basically a 63.5, 63.5, 53 degree triangle. So all three angles are less than 90. So not only is this triangle isosceles, it is acute. And we have demonstrated that we know this because we found the angles and we found the side lengths. So just by solving the triangle, we were able to figure it out. Okay, so for a triangle, that's not too bad, right? Let's look at a couple quadrilaterals. Okay, kite, trapezoid, parallelogram. There's lots of shapes out there for quadrilaterals. So again, we're going to stick in the first quadrant just because it was easy to throw it in the first quadrant. Okay, Q is going to be at 2, 5. So 1, 2, 3, 4, 5. I'm just going to mark where 5 is on all these. So Q is at 2, 5. R is going to be at 7, 6. S is going to be at 6, 1. And P is going to be at 2, 1. Okay, well, it definitely does not look like a parallelogram because this has us, we can see our slopes. So if we find our slopes and our distances, then we should be great to go, right? So slope and length. We'll just go with length instead of distance. Maybe that'll sound better to some brains. It's up to you. Okay, slope and length. And we have P to Q, Q to R, R to S, and S to P. Those are the ones that we need to worry about. So if we can see S to P or P to S has a slope, it's flat. S is at 0 slope. And Q to P is straight up, so this is the undefined slope. So that automatically makes this a 90-degree angle because that's what happens when you have a flat line and a vertical line, right? let's see, we have to go up 1 over 1, 2, 3, 4, 5. And here we'd have to go 1, 2, 3, 4, 5, 1. Okay, so nowhere else do we have perpendicular angles. Okay. So what about their lengths? Now when they're flat, they're really easy to get their lengths. We just count 1, 2, 3, 4. So this had a length of 4, and 1, 2, 3, 4. This also had a length of 4, so they're congruent. Okay. So now Q to R, we'd have to go 1, 5. So to get the hypotenuse, it'd be 1 squared plus 5 squared. Would give us the hypotenuse squared, and then we'd square root it. So 26, root 26. That's Q to R. And we have 1, 1, 2, 3, 4, 5. Hey, the same numbers. So that would also be root 26. So this is congruent to that. So we have adjacent sides congruent. Because we have adjacent sides congruent, that is the definition of a kite. And when you think about it now, can you kind of see how you could add your one post vertically and your other one, attach your tail and your string, and have your streamers? Yeah, the kite's hanging upside down. It happens. So we found a kite. Why was it a kite? The adjacent sets, these were congruent, these were congruent. So P was equidistant from this point, R was also equidistant from that point. All right, let's try one more. Let's see what we get. One, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, W. Ooh, unblurry, please. W is going to be at 2, 2. Come on. There we go. And X is going to be at 4, 7. Y is going to be at 7, 5. And Z is going to be at 4, 1. So we have a quadrilateral W, X, Y, Z. So we need to find out our slopes so we can find out if anything is parallel or perpendicular. And we need to find out our length so we can find out if anything is congruent. So we have X to Y, Y to Z, Z to W, and W back to X. We need the slope and the length or the distance. Okay, I like doing slope first, so W to Z is the easy one. That did not go up or down, so 0 fun to sled on, right? We have 1, 2, 3, 4, 5, 6, 1, 2. So we went up 6 over 2. So 6 over 2, that would make 3 over 1. So that's W and X, slope of 3. Now, I'm going to go ahead and do the distance at the same time. WZ it was easy to see the distance of 2. WX, a squared plus b squared equals c squared. So we'll just square root that. So that would be the square root of 40. Or if you needed it simplified, 2 square roots of 10. Okay. X to y, 1, 2, 3, down 2. So that's down 2 over 3. Okay. And if we did a squared, oh, come on, boy. A squared plus b squared equals c squared. We'll be square rooting that. 4 plus 9 is 13. Okay, we've got one more to do. It's obviously an uphill line, right? 1, 2, 3, 4. 1, 2, 3. Well, that's easy. It's a 3, 4, 5 triangle. And up 4 over 3. Okay. Our slopes are all over the place. No parallel, no perpendicular, so no sets of parallel sides. And our side lengths are all different, so no sets of congruent sides. So because there's no parallel, no congruency, this is just a plain old quadrilateral. It has 4 sides. It doesn't have anything special to it. Okay? If your teacher gives you a formula sheet that has the distance formula on it, do you have to do Pythagorean theorem each time? No, absolutely. Go ahead and grab that formula sheet. Otherwise, make sure that you're double checking what you need to. And really, especially if you're going to have to go into coordinate proofs, that you understand how to write it down, what you're doing, so that you can demonstrate it for somebody following your logic.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? And drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.